Microsoft Graph is a powerful API that provides a unified endpoint to access a wide range of Microsoft 365 services. It allows developers to interact with data from services like Azure Active Directory, Outlook, OneDrive, Teams, and more. By leveraging Microsoft Graph, developers can build applications that integrate deeply with the Microsoft ecosystem, enabling functionalities such as user authentication, data retrieval, and service automation. Implementing solutions that interact with Microsoft Graph is crucial for enhancing Azure security. Microsoft Graph provides access to security-related data and insights, such as user activity, threat intelligence, and compliance information. By integrating these capabilities, developers can create robust security solutions that monitor, detect, and respond to potential threats, ensuring a secure environment for Azure resources. Authentication and authorization are fundamental aspects of interacting with Microsoft Graph. Developers must register their applications in Azure Active Directory, AAD, to obtain the necessary permissions. This involves configuring OAuth 2.0 authentication, acquiring access tokens, and managing user consent. Proper implementation ensures secure access to Microsoft Graph APIs, protecting sensitive data and maintaining compliance with security standards. One of the primary use cases of Microsoft Graph is accessing user data. Developers can retrieve information such as user profiles, emails, calendar events, and files stored in OneDrive. This data can be used to create personalized experiences, automate workflows, and enhance productivity. For example, an application can fetch a user's calendar events to provide reminders or integrate with email services to send notifications. Microsoft Graph also enables developers to manage Azure resources programmatically. This includes creating, updating, and deleting resources, such as virtual machines, storage accounts, and databases. By leveraging Microsoft Graph, developers can automate resource management tasks, ensuring efficient and consistent operations. This capability is particularly useful for large-scale deployments and dynamic environments where manual management is impractical. Monitoring and reporting are critical components of Azure security. Microsoft Graph provides access to various logs and metrics, allowing developers to track user activities, resource usage, and security events. By integrating these insights into custom dashboards and reports, organizations can gain visibility into their Azure environment, identify potential issues, and take proactive measures to mitigate risks. Microsoft Graph offers advanced threat detection and response capabilities. Developers can access security alerts, threat intelligence, and vulnerability assessments through the API. By integrating these features into their applications, organizations can detect suspicious activities, analyze threats, and respond promptly to mitigate potential security breaches. This proactive approach helps in maintaining a secure and resilient Azure environment. Compliance and governance are essential for maintaining security and regulatory standards. Microsoft Graph provides access to compliance-related data, such as audit logs, policy settings, and compliance scores. Developers can use this information to ensure that their applications and Azure resources adhere to industry regulations and organizational policies. This helps in achieving compliance and avoiding potential legal and financial repercussions. Automation is a key aspect of modern security operations. Microsoft Graph enables developers to automate various security tasks, such as user provisioning, access reviews, and incident response. By leveraging automation, organizations can streamline their security processes, reduce manual efforts, and improve overall efficiency. This ensures that security operations are consistent, timely, and effective in protecting Azure resources. Microsoft Graph can be integrated with other Microsoft and third-party services to enhance security solutions. For example, developers can combine Microsoft Graph with Azure Sentinel for advanced threat detection and response, or integrate with Power BI for comprehensive security reporting. These integrations enable organizations to build cohesive security ecosystems that leverage the strengths of multiple services, providing a holistic approach to Azure security. Implementing solutions that interact with Microsoft Graph requires adherence to best practices. Developers should follow security guidelines, such as using least privilege access, regularly reviewing permissions, and implementing robust authentication mechanisms. Additionally, They should stay updated with the latest API changes and security updates from Microsoft. Following these best practices ensures that applications are secure, reliable, and compliant with industry standards. To illustrate the practical application of Microsoft Graph, consider a case study of a company that implemented a security monitoring solution. By integrating Microsoft Graph with their existing security tools, they were able to gain real-time insights into user activities, detect anomalies, and automate incident response. This resulted in improved security posture, reduced response times, and enhanced compliance with regulatory requirements. This case study demonstrates the tangible benefits of leveraging Microsoft Graph for Azure security. The landscape of Azure security is constantly evolving, and Microsoft Graph is at the forefront of these changes. Future trends include enhanced AI-driven threat detection, deeper integrations with other Microsoft services, and expanded API capabilities. Developers should stay informed about these developments to leverage new features and capabilities, ensuring that their security solutions remain cutting-edge and effective in addressing emerging threats. In conclusion, implementing solutions that interact with Microsoft Graph is essential for enhancing Azure security. By leveraging its comprehensive API capabilities, developers can build robust security solutions that monitor, detect, and respond to threats effectively. The next steps involve exploring Microsoft Graph documentation, experimenting with API integrations, and staying updated with the latest security trends. By doing so, developers can ensure that their Azure environments are secure, compliant, and resilient against potential threats.